Okay, folks, I'm back again. What we want to do is talk about this assignment 1.1 through 3, but I want to show you a couple of things here that I really find they're almost hard to believe that this is the case for someone your age. It's hard for me to believe. I graduated from high school in 1968. That's pretty scary in itself. I was born right at the turn of the previous century. Anyway, when I was going to high school, elementary through high school or whatever, until I got to be about a junior in high school, I had to do multiplication and division, addition and subtraction, all that sort of stuff like everybody does now. The only way to do that was with pencil and paper. The only way. Now, they're like adding machines, okay, that people like in businesses had, but didn't take that to school. And there were computers, but basically, there are very few people were doing math on a computer, so you just had to do it by hand. So when I was doing the stuff you're going to be doing in physics, I did all this stuff that you're going to be doing, and I did it, and everybody else did this just with pencil and paper. Now, what happened when I was about a junior in high school was I don't remember what class I was in, but our teacher taught us how to use a slide rule. And this was what, at that time, everybody who was doing science and whatnot, college professors, you name it, rocket scientists, yes, they were rocket scientists, and this is what they used. And let me just show you one. This is almost exactly like the one I had. Mine is buried under a bunch of junk here at KT, and I can't find it, but it's based on logarithms, and here's the idea. Suppose I want to multiply 2 times 2.5. Okay, well, I'm going to drag this little thing right here until this little marker right here, this little 1, is over the 2. Okay, so I've gone over 2, but I've actually gone, notice this is nonlinear. I've actually gone over by the log of 2. And now I'm going to go over again by the log of 2.5, and this total distance from where I went all the way over here to over here is the log of 5. The antilog of 5 is this right here. So what you're doing is you're adding logarithms and then taking the antilog to get the product. And this does this physically with this linear system. Likewise, suppose you want to take 5 and divide it by 3. Okay, you bring this thing over here to 5. So you've gone over 5, and then you drag this so that the 3 is over the 5, and so you go back by really the log of 3 to this right here, and this number right here, 1.61 or whatever, that is the answer of 5 divided by 3. That just seems, and by the way, this stuff up here, there's logs, and base 10 and natural laws. This is a very simple version of this calculator, of this slide rule, but that was what everyone used. It's bizarre. Well, anyway, if I ever find one, I'll bring it in, because it had a nifty little case, and people actually wore them hanging down from their belts, and it was geeky. All right, now, and when I went to college, when I started teaching physics labs in college, probably in '72 or something like that, and the Hewlett-Packard Company had invented the first handheld calculator. It wasn't like the first ones after the little 4-function ones that ever. The very first handheld calculator was this thing right here, and it was the HP 35. And I don't know why they started off with the 35, but there it was. It cost $400. And in the lab where I worked, I was teaching physics labs, and to help students be able to do their homework and stuff, the university bought 2 of those, and the people actually from Hewlett-Packard came and attached to them the desk. They had keys to lock them down to keep people from stealing them. And this is what they cost, $400, and this is what we had. And so all the physics students came and did our homework there. That Christmas, my mother got me one for Christmas, and I just about fainted. $400 is what my college tuition was. And I got it for Christmas. Okay, so anyway, that really changed everything. Incidentally, years ago, I called the HP people saying, you know, I've still got the old HP 35. They go, yeah. You want us to fix it? He says, we don't want to hear about it, because everybody that has one of these things wants it to work because it was the original. Anyway, I hope you find that as fabulous as I do. But incidentally, I don't use a handheld calculator at all. I use an iPad for calculating. I use, what is it, Power 1030. What is it? What is the name of it? I had that written. I can't remember what it's called, but anyway, I use an app. And the only reason that I don't use a regular handheld calculator is because on an iPad you can edit. You can touch in the middle of a big long number and delete the character and replace it and stuff. You can copy and paste and things. So anyway, that's my deal on all that stuff. Okay, real quickly here, and I really am serious. Okay, real quickly, let's look at this assignment here. You have an introduction to how the thing works, and one of the things it tells you to do here is to take that printout copy of your homework, which I've talked to you about, and I don't have a copy to show you here. It has space for you to work on, and I ask you to work these problems out there on. Now you won't do some of these problems. You'll do strictly just on your calculator, but generally speaking, you'll write down your solution on that piece of paper and then transfer it to our system. And we'll be learning in here about good problem solving techniques, which, trust me, nobody ever trusts me. And trust me, it makes a huge amount of difference to do it a certain sort of way, where you write down what you know and what you want to know and all this kind of stuff. So anyway, I'm printing out that stuff, the copies of the homework, so you'll have a place to do this stuff, and it leaves you space to do the calculations. So do that work in pencil, enter the answer in, and see how you did, because you can just enter your answer and hit whatever it is. It's not submit, but whatever. It's at the bottom of the page, and it'll tell you how you did on all those problems. So that's what you want to work on doing here. Now, so that's kind of the introduction here. There is also this little deal right here. This is the homework, and I'm going to open a new tab so it won't go away. And here is the homework. Here is the homework coming now. Hi, Sally. Okay. Now there's another introduction over here, and this is kind of going over the top a little bit, but one of the things, this is all about, or part of it's all about just doing math. And in this class, you're going to have to do things like solving this equation for r. Now this is by far the worst equation you'll see in here, by far. This is an equation that tells the period, which is the time something that repetitive takes, the period of a planet around another body. This is the mass of the well, actually this is the mass of the body it's going around. So this is like a moon. Say if it's a moon, this is the mass of the planet it's going around. This is a constant, and this is the radius of the orbit, not the planet, and this is the period of, say, the moon going around it. You need to solve that r to the 3/2 for r. Now, if you solve this problem strictly just using a calculator, you won't be developing the skills you need to do stuff like solving this for r to the 3/2. So in this homework assignment, you're going to find you're going to have stuff like this where I want you to solve something that has numbers in it like that, something to the 3/2. And I would like for you to make sure that you try to do those things by hand. And maybe it'd be better if I had just had to show you what I'm talking about. Let's go ahead and look at this assignment. Okay, yeah, continue. Okay, you see, now these are Sally's answers here, and they may or may not be right. Okay, now look at this problem right here. 1.6 times 10 squared times 3 times 10 to the 6 times 2 times 10 to the 11th. You can do that. You should be able to do that problem in your head. Even without the paper, you can do that problem in your head. Because you multiply 1.6 times 3 times 2, so that's going to be that number right there, times 10 to the what? It's 10 to the 2 plus 6 plus 11. That sort of skill, knowing how to deal with multiplying things to powers together, you need to understand that. So on these problems like this, yes, the calculator will get the answer, but for things like this where you go, man, I don't know if I could do that by hand or not, you need to do it by hand to make sure you can. And so use that paper that I provided there for you to write that stuff down on. Okay. And on. Now this goes on for a long time. And I say, here's something to the 1/3 power. What is that? That's the cube root. How about the minus 1/3? That's the 1 over the cube root of it. Okay. And so all those kinds of things are in here. Okay. We're just trying to make sure you can get all those things to work. Okay. Now, so now back to the, no. Is that where I was? Back to the beginning here, back to this assignment. Okay. Now, look at these instructions right here. It says you're going to use this ebook right here. And what it tells you to do is do the activities on pages 4 through 15 in the ebook. I'll show it to you in a moment. These cover typical problems, blah, 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 blah. Then do this section of homework. Then do these other activities and do this homework. Okay? So do these pages and do this thing right here. Okay? Now, the ebook. I'm going to click on that. It should open up in a new window. Yep. This is entirely created in Flash. It is the most insane thing that I ever did with coding. It's just completely nuts. And I only use a tiny bit of it now. Alrighty. Now, this is a flip book. It's full of stuff like this. I'll come back here. And when we get to chapter 3, you'll do the trigonometry part of this thing and the geometry part, but you're not going to do that here now. Now you need to move from page to page. Okay, this is a flip book. If you click in the corner like that, it'll flip the page. Now if that happens to be over this Powered by Magazine, it'll go to that website instead. So if you wonder what happened to your page, that's it. You can also click this page up here. Okay, so that flips the page. This is going really slowly here. Okay, and this is a bridge right outside of Medicine Hat. I'm sure you all recognize that. All right, now here's what's going on in here. You have these are just a bunch of animations about things you learn about in physics, but here is the introduction to the SI unit system. You should know about this. Here are the basic units of measure that we deal with in physics, but we also do with combinations of those things like kilogram meters per second squared and stuff like that. And this activity is going to help you learn about those things. So let's turn a page. So you would read that stuff. And by the way, these little dots down here also will jump to pages. You just click on the dot and it goes to that page. Okay, this is about how units work together when you have more than one number and they have some kind of combination of units. How many times longer is a 214 meter train than a 72 meter train? That's a tough one, right? Okay. Was that 32? Nope. Is it 3.2? Is it 356? Nope. Well, I don't know what it is. You're going to have to figure that out, okay? But this is strictly a division problem, right? The point of this is not can you divide 214 by 72. The problem is, what about those units, okay? When you divide meters by meters, what do you get? You get no units. The units cancel out, okay? So your number here is just going to be this number divided by that number, which I'm certain that you all can handle, okay? Now, how about this? We have two 6-meter tall trees placed end to end. Their total length would be what? Another very difficult question. Well, it's going to be 12 meters, right? Here's the way this works. Click on the 12, click in the space. Click on the meters, click in the space. Let's check it and see how we did. Both turned green, so you're good. Now, a square plot of land is 6 meters by 6. Oops, that should have a meter right there. That's weird. Okay, and that would be 36. Of what times the size of one square? That is so bad of me, because that's actually wrong. That's correct. Let's do this one. Well, let's see. Shoot, because there shouldn't be a unit there. 6 by 6 meters should be 36 times the size of one. Well, I'll tell you what. I'll have to fix that error. By the time you see it, that'll be gone. I'm having you put meters squared in there, which is wrong because I wrote the problem wrong. But you see the point. You click on these, click in this blank, and click the check, and it tells you if you're right or not. So what's going on here is you're saying, oh yeah, okay, when you multiply units together, you multiply the units together. You know, if you multiply a length times a length, you get an area. Okay, and here is converting from square meters to hectares. How do you know how to figure that out? Well, it might be that hectares to meters squared are in the back of the book, but you can go online to find what that is. But this is about conversions of units. So how do you do that? You'll take 36 meters squared times hectares per square meter. So you need to find out the relationship between hectares and square meters by looking it up. Okay, and you put your number in there and check it and see. Here we have another problem here that's teaching you a lesson about electric current. So we have coulombs, which are units of charge, and we have amp seconds. Amps are units of current. And an amp is a coulomb per second. So you're going to be doing a little thing with dividing units, and it just goes on like this. And everybody has always found that this worked out relatively well, except nobody's ever complained about it. I think I may have just edited that problem and fouled it up. Okay, then we do scientific notation. Now, by the way, when we talk about scientific notation, it is always standard form scientific notation. Okay, the decimal goes after the first digit when you write the number down. Sometimes you want to adjust that temporarily to make it easier to solve a problem, but the numbers always look like this. And oh, by the way, and I should have thought of this, and red alert, in your homework, oh boy, let's see if that's back there. Let's see, I've got a, oh yeah, here we go. Here's this answer right here. 8e minus 3. 10 to the minus third is written as a little e minus 3. Okay? So you do scientific, anything you do on computers is done that way. So e minus 3 is 10 to the minus 3. And so there we got that. Well, that was a happy occurrence. Okay. So that's scientific notation stuff. And on you'll see as you go through here that I'm just reviewing you, or maybe things you hadn't seen in a long time. I'm kind of, or maybe you've not seen it before, so you're going to learn it now. Converting units. Why is anything to the 0 equal to 1, which is on the left-hand side, which I only know because I just started graphing. That I don't know. I still don't know exactly why, but I was able to prove it by graphing, and that's what's there. And then more on scientific notation, etc. So anyway, getting back to the assignment, your assignment was to do all these little activities, do this homework, do the other activities, and do the second homework, and you're done. That's more than I meant to say, but that's all I had to say about this. Good luck with it, and we'll catch you later on.